Welcome to the Q2 2025 session of the What's Next in OpenShift. Here we will give you a glimpse of the product roadmap, direction, initiatives, and exciting new features and use cases to look forward to in the next 6 to 18 months. My name is Nick, and with me today I have a terrific team of OpenShift product management colleagues who will be joining me as speakers. And in addition, we have the rest of the OpenShift team to help answer questions. Viewers, if you do have questions, please feel free to add them into the comments section in the live stream, and we will do our best to get back to you with a response. Red Hatters, feel free to check the calendar invite for additional communication channels. We are excited for any kind of feedback, as many of the features we work on are heavily influenced by our customers. And with that, let's go ahead and get started. So for organizations that run their businesses on software, which is almost every organization today, the quality and speed of delivery of those software solutions is key to the organizational success of the company, especially in the emerging age of AI. Almost every facet of our daily lives nowadays is touched by software applications. Just think about the number of applications that you use on a daily basis. We use them for almost everything, including banking, insurance, shopping, travel, and streaming of movies. More than ever, your software strategy is your business strategy. And the ability to roll out new and improved digital business services and products continuously will be the difference between the companies that stagnate and the ones that evolve. Of course, agility and new technologies come with challenges, and some of which you will see here. Some of these challenges have been with us for some time, and others have been new and or are increasing. In the last year, we've seen an increase in the use of intentional AI, and we don't anticipate that this trend will change anytime soon. In the hands of Red Hat customers and employees, AI is already being used to create new content and develop useful tools. But in the wrong hands, AI can be dangerous. Gartner predicts that AI use will result in roughly a 50% decrease in the time needed to exploit account exposures, as well as cause roughly 40% of all data breaches by 2027. The sudden acceleration in AI increases knowledge gaps and the adoption gaps that developers must address, and modifies the threat landscape. Recommendations for securing infrastructure and application supply chains apply equally across all types of solutions, including AI application platforms and AI-enabled applications. However, organizations still struggle today to update existing tool chains and processes. That is why you need an application platform that is trusted, comprehensive, and consistent. Whether you're running in the cloud, on-premises, or at the edge, you need to know that your platform is trusted, that the software supply chain used is reliable and secure, not just for the platform, but for your applications as well. Additionally, it needs to be comprehensive, meaning that it will encompass all aspects of your software development. And finally, it should be consistent. You know that it will work and how it will work, regardless of where it is based. In 2024, Red Hat was named the leader in the Gartner Magic Quadrant for container management, as well as the Magic Quadrant for cloud application platforms. As a leader in the Gartner MQ on container management, Red Hat OpenShift was recognized as the product with the most comprehensive stack, ranging from support for bare metal deployments to self-service cloud services. In the Gartner Magic Quadrant for cloud application platforms, Gartner noted Red Hat's strength in offering strategy, market responsiveness, and business model, with strong hyperscaler partnerships and ecosystem integrations. Gartner recognized Red Hat OpenShift Cloud Services as the product with the most flexibility in where to run the platform and relative ease of portability across cloud providers, on-premises, and platforms. So as mentioned previously, our roadmap is heavily influenced by our customers. And as we approach 2026, we're focused on four core areas, including the acceleration of use of AI, securing the OpenShift platform and application workloads, and modernizing applications and infrastructure, and managing at scale across data center, public cloud, and at the edge. We are looking forward to enhancing your experience on OpenShift by enabling AI workloads on the core OpenShift platform and accelerating MLOps to build more intelligent apps with OpenShift AI. Additionally, we plan to infuse Red Hat OpenShift with Lightspeed, a generative AI service to help users work with Red Hat products more efficiently. Security is paramount to us to everything we do. We continue to incorporate security throughout the platform and application lifecycle, as well as add increased functionality to enable supply chain security. We have been working on zero trust networking and confidential computing in OpenShift for some time now, and are looking to add zero trust federated workload identity management capabilities and expand our confidential computing and post-quantum cryptography solutions. To accelerate application and infrastructure modernization, we plan to increase developer productivity with OpenShift developer services, bring VMs to a cloud-native platform with OpenShift virtualization, and provide universal connectivity via user-defined network enhancements and the GA of ambient mesh, gateway API, and its integrations. Finally, enhancements to OpenShift Platform Plus allow you to manage and secure your platforms and apps at scale across your fleet. Or you could accelerate your own adoption and reduce operational overhead with OpenShift Managed Cloud Services. Whether you run on AWS, Azure, Google, or IBM Cloud, you will be able to scale apps to edge servers, devices. You can even scale apps to edge servers, devices, with OpenShift and Red Hat Device Edge, and enable new edge form factors. Now let's dive into some of the Spotlight features. But before we jump in, a small logistical note. You will see us use this terminology of near, mid, and long term for our roadmap items. This roughly pertains to a 6, 9, and 12-month timeline, respectively, just for your note. So, onto the Spotlight features. In this section, we will highlight some of the key features that we are excited to bring to you soon. And for starters, we will open with OpenShift Lightspeed. For those of you new to the topic, OpenShift Lightspeed is available as an operator that integrates its chat UI into OCP console. Now, the user can use this chat UI to ask OpenShift-related questions or inspect their pod resources using natural language. We support flexible LLM architectures where the customer can bring their own LLM provider from a list of watsonx, Azure AI, OpenAI, Red Hat OpenShift AI, or RHEL AI. OpenShift Lightspeed also works in a disconnected mode, and customers can use RHEL AI to OpenShift AI as an LLM provider. As you can see in the slide, the OpenShift Lightspeed tech preview has tons of functionality already, and we will obviously be working towards bringing that to GA in the near future. But what other things are we investigating to add in the flagship operator? Well, of course, there are several things we want to look to improve. First, we want to see if we can bring more cluster awareness to the command line so that you can ask about the state of your cluster and get recommendations. In addition, maybe you have your own knowledge that you want to bring to OpenShift Lightspeed, a specific deployment rule or a runbook that you would like to include in the feedback. In reality, this means the ability to add additional knowledge sources. And of course, Red Hat will be including other OpenShift products and knowledge sources at the same time. Now, we also continue to deliver innovative solutions that enable organizations to accelerate and streamline the development, deployment, and management of AI-enabled applications and Gen AI across private data centers, cloud, and edge environments. To that end, we are enhancing OpenShift and working to modernize its core APIs to better align with the needs of AI inference, LLM, and distributed AI workloads. 3 core areas that we are focusing on are platform optimization, where we will have a registry to support AI models. We are using Quay to store, serve, and distribute AI models. Additionally, we will optimize resource utilization and management via the Dynamic Accelerator Slicer, or DAS, which is in dev preview. This lets you dynamically allocate and manage AI accelerator resources, such as GPUs, to optimize the performance of data science models. The dynamic resource allocation, or DRA, specifically when attribute-based, involves assigning resources such as CPUs, memory, or specialized hardware to tasks or workloads based on their specific needs and the system's current state, rather than using a fixed allocation. Resources are dynamically adjusted and often using structured parameters and device classes to optimize performance and resource utilization. Finally, with respect to workload orchestration and scheduling, we have Queue, which is a Kubernetes native job queuing system for batch workloads. JobSet, which is an API for managing groups of related batch jobs as a unit within a given workload, which facilitates the deployment and orchestration of distributed tasks, especially for HPC and AI and ML training applications. Finally, the leader workset is a resource for coordinating leadership across multiple workloads. Now, let me walk you through several of the key updates in OpenShift's support for AI infrastructure. First, the NVIDIA B200 GPU is now supported through NVIDIA GPU Operator version 25.3.0. Both HGX B200s and DGX B200s are certified in the Red Hat ecosystem catalog, giving customers access to cutting-edge performance and full enterprise support. We've documented the full configuration process for multi-node, multi-GPU deployments using GPU Direct RDMA. This enables high throughput, low latency communication between GPUs across nodes with row CE or InfiniBand, which is essential for large-scale AI models. We already support the NVIDIA Grace Hopper Superchip, and we are actively preparing to support the Grace Blackwell GB200 NVL72 platform, bringing the next generation performance capabilities to OpenShift. We are working closely with NVIDIA to enable OpenShift virtualization on HGX servers with NVSwitch. This includes integrating the Fabric Manager, which will streamline deployment and management of these powerful AI platforms. On the AMD side, AMD GPU Operator now provides AMD GPU health monitoring, and the operator provides real-time health checks through a metrics exporter and integrates with the Kubernetes device plugin to automatically remove unhealthy GPUs from a node's schedulable resources. We are collaborating with OpenShift virtualization to support using AMD's new ROCm or GIM drivers. This is part of our roadmap, which will expand GPU virtualization options in the future releases. Finally, we've introduced a new telemetry dashboard directly into the OpenShift web console to monitor AI accelerators. It will provide real-time insights into GPU performance and power usage, including memory utilization, clock speeds, and energy consumption. This built-in view helps administrators quickly assess workload efficiency and system health without relying on external dashboards. Finally, security in OpenShift has always been a key differentiator. Here are some of the exciting features in security that we are focusing on. Firstly, bring your own OIDC on standalone OCP so that you can authenticate users and groups directly into the Kubernetes API server. Will be coming as tech preview in 4.19. We are also enabling secure workload deployments on OpenShift with least privilege approach, which is aligned with the Kubernetes community's restricted pod security standards. We plan to promote restricted enforcement to GA in the second half of 2025. We've already tech previewed running pods on Linux namespaces, and we're planning to GA this. This allows running pods on their own namespace and not on the root, which is the default. Doing this mitigates breakout risk by isolating each container's namespace, adding a layer of security for other containers and the hosts. Additionally, in order to improve security of secrets living on OpenShift clusters, we will be adding kubekms support to encrypt data in etcd, as well as support for the external secrets operator, which will help manage secrets stored in third-party management solutions. To reinforce the shift left and provide a practical and scalable way to establish content trust, we are working to simplify signing cloud-native artifacts by adding the cryo support for SigStore, which is including signing and verifying artifacts in OpenShift. On the confidential computing front, we are actively advancing multiple initiatives to deliver fully trusted execution environments within OpenShift to protect data in use, spanning both cloud and on-premises deployments. And finally, with Red Hat's Zero Trust Workload Identity Manager based on the upstream Spiffy and Spire projects, we provide a single identity framework for secure communication between workloads in a multi-cluster, multi-platform environment. This will be covered in detail during the security highlights. In the world of virtualization, Red Hat is excited to bring some exciting enhancements to OpenShift virtualization. This will focus on workload mobility across infrastructure by moving storage classes to GA. This will introduce mobility of clusters without disrupting workload availability and will be a feature available via our migration toolkit. This will allow live migrations across clusters non-disruptively. We're also making it easier to have smaller migrations managed through an assisted migration utility. We are also bringing multi-tenant networks to VMs by adding secondary UDNs that are more flexible and adding support for single-stack IPv6. Multi-cluster VM management for large-scale implementations is another core area of focus. By combining the OpenShift virtualization with Red Hat Advanced Cluster Management, we will be managing VMs at scale much easier. Red Hat Advanced Cluster Management offers specialized dashboards that target VM observability details in your VM, such as CPU usage, network metrics, and cluster stats. Additionally, our Red Hat ACM is becoming the one-stop shop to control VMs across your entire fleet. Finally, we will be broadening the platform support and cloud support. We currently have support for ROSA and AWS. We have announced Oracle OCI and GCP as tech preview, and we are working with another major cloud vendor to be announced later. Finally, we introduced Linux One S390 platforms in 4.19 as a tech preview, and we'll be moving it to GA soon, along with ARM support. Lastly, an exciting feature coming to tech preview in 4.19 is the improved OpenShift virtualization onboarding experience. This enhancement will deliver a streamlined, opinionated installation workflow that leverages existing tools like the agent-based installer, the assisted installer, and OpenShift appliance. Some of the highlight features are disconnected installation, meaning that there's no registry required. Installation is completely self-contained and means that you can get the full cluster deployed without needing an external image registry. For customers running in air-gapped or secure environments, this removes one of the biggest pain points of the setup process, including setting up a local registry. We will also have a UI-driven workflow. The assisted installer UI is now hosted locally right on the proto cluster during installation. So instead of writing YAML or running CLI commands, the admin gets a guided UI-based workflow to configure things like networking, storage, and host roles. And finally, an opinionated workflow with pre-configured operators. We will pre-configure the core operators needed for OpenShift virtualization so the users aren't left guessing what needs to be installed on day one. This reduces complexity, especially in disconnected setups, and can help them get to a functional virtualization environment much, much faster. So up next, we are going to present the core platform via Ramon. Thank you very much.
Thank you, Nick. Next slide. And let's start with OpenShift onboarding and lifecycle. We continue to expand our support for new cloud providers and platforms, onboarding new regions, adding support for different architectures, and enabling third-party provider integrations. For example, as Nick just mentioned in the Spotlight section, a notable highlight we have in store is a tailored onboarding experience with OpenShift virtualization. With hosted control planes, we continue to make enhancements in lifecycle management, in networking and security, as well as cross-cloud integrations and cluster capabilities. On the update front, our focus remains on ensuring a stable and consistent update experience. Notable features here are an update pre-check command, an update progress monitoring CLI, and we continue to invest in the update experience for disconnected and air-gapped clusters. But let's take a look at what's coming in more detail. Next slide. OpenShift is all about hybrid cloud and cloud native across the various cloud providers. Top of our list is to make sure you have a consistent experience no matter where you run your OpenShift. So let's take a look at what have we planned for cloud providers now, starting by networking. As we see demand in rise for dual stack IPv4, IPv6 networks, we'll continue to work to provide support across AWS, Google Cloud Platform, and Azure. You will be able to configure your own DNS service at install time on AWS and Azure, reducing post-install configuration. And talking about reducing day two admin tasks, we are also bringing the ability to define additional disks at install time on AWS, Azure, and Google Cloud. We've already mentioned some of the fantastic things happening with OpenShift virtualization. Here we also plan to bring support, as Nick previously covered actually, for Google Cloud and Oracle Cloud. And we're adding support for deploying OpenShift on dedicated hosts in Azure and AWS. This will help meeting compliance requirements, especially when licensing or regulatory rules require dedicated physical host control. We'll add new AWS regions this time, including Mexico, Taiwan, Saudi Arabia, and Auckland. Support for private and restricted endpoints on Google Cloud is coming too, allowing to interact with Google Cloud APIs without being connected to the internet. We're enabling OpenShift on AI and ML focused Azure VM families, supporting workloads that need GPU acceleration and/or high memory. And finally, we are looking at bringing OpenShift support for Oracle Cloud Roving Edge and Oracle Alloy Cloud offerings, continuing with our investments in Oracle Cloud infrastructure. Let's go to the next slide. Let's talk about enhancements across providers for OpenShift on-premise now. And starting by bare metal. For bare metal, we are adding day 2 firmware settings, reconfiguration and updates, multi-architecture support, and bare metal as a service. Keep an eye on bare metal as a service. This may make your experience with OpenShift much better, right? Beyond OpenShift itself, you will see. vSphere will support zones, that is Kubernetes zones with host groups this time for better workload placement. Multi-disk and multi-NIC support is coming as well at install time, and the ability to add bare metal nodes to vSphere clusters. And think about this one, you will be able to expand your OpenShift clusters on vSphere without having to expand your vSphere cluster itself with new ESXi nodes, right? You will dedicate entirely your new hardware to bare metal. This is an exciting feature we are adding to OpenShift. On Nutanix, we'll add static IP assignments, agent-based installer support for more custom deployments for Nutanix, multi-prism central failure domains for higher availability, like we did with vSphere actually, and the ability to add bare metal nodes to Nutanix cluster, similar to the feature, or the same actually, feature that you will see with vSphere. OpenStack, we are advancing with Red Hat OpenStack services on OpenShift with multi-OpenStack deployments, with workloads optimizations, federated authentication, confidential computing, and more. And for IBM, we are leveraging unique features like Secret Store. We are adding IPv6 single stack support in this case, and AI enhancements like DRA for GPUs. Let's go to the next slide. And let's take a look at what's next for hosted control planes and other core OpenShift areas. Starting by hosted control planes. Hosted control planes is a fantastic technology. I'm the relatively new product manager for HCP, so I'm pretty excited about this one. And it will sit, and it sits now at the core of many cloud-based offerings. So particularly today, it sits at the core of ROSA and Arrow. This is really an exciting area with loads of plans in place. In the next releases, it will feature streamlined upgrades, dynamic control plane scaling. This is essentially now in the future for ROSA and Arrow, but it will apply to hosted control planes in any platform. Improve debugging, ROSA and Arrow HCP enhancements in general. ROSA and Arrow are key in the future for hosted control planes this year and next year. This is a key area. Third-party CNI support. We're starting with Cilium and Calico and more. OpenShift Core. OpenShift will feature dual stream AUKUS 9 and 10 updates in the same cluster, container swap support, username spaces with PSA enforcement, bring your own OAuth and OIDC, Prometheus integrated the scheduler, and more. And OpenShift storage, it will include recovery from expansion, a tech preview for the volume attribute class, vSphere volume migration support, and more. Let's see the next slide now. And control plane. Let's now take a peek at the control plane in general, where upcoming enhancements include the ability to fine-tune The event TTL and go away chance attributes aimed at large-scale clusters. We are seeing a lot of interest in running OpenShift in larger and larger scale clusters, many nodes, and we need to enable more fine-tuning to allow high performance and efficiency to these clusters. So these two features are in our roadmap. If you have been looking into improving your large clusters, stay tuned because this will really help you. Also, hitless etcd defragmentation and certificates rotation, meaning you won't even notice in any service when etcd is defragmenting the database or when we are issuing a rotation of the platform certificates. This integrated with kubekms. We are introducing also kubekms integration for being able to use key management services from other providers. A new control plane documentation section. Currently, we have many sections in our documents already, but the control plane is a really important part of OpenShift, and we will dedicate a section with coverage for many of the content that you usually ask us about performance and tolerations and recommendations in general. We'll be adding in the future external CA support. This is for platform certificates and an improved platform certificate rotation information for users to query directly. And next slide for managed OpenShift services.
All right, next slide, please. Thanks, Ramon, and thank you so much for hosted control planes. We're loving it over here. So in this section, I'll cover new exciting features planned in our 3 different OpenShift cloud services. So first, let's start with Red Hat OpenShift service on AWS, or what we call ROSA. First one is allowing admins to deploy and maintain private ROSA HCP clusters without any public egress required, essentially air-gapped. This will enable customers to meet their compliance and security requirements and have tighter control over clustered network egress. Next up is enabling license-compliant Windows workloads on OpenShift virtualization, including both BYOL and license-included options. This allows Windows customers to bring both old and new licenses to our service, only paying for what they need. Next, we're giving customers the ability to reserve capacity for their GPU workloads and what AWS calls capacity blocks for ML. This helps guarantee the availability of GPU instances when needed. In addition, we're giving longer-term support for our managed services by including EUS channel by default. This enables customers to stay on the same version of their managed services as on-prem, making it easier to maintain a hybrid environment. And finally, we are adding a couple of cost-saving features. First, we're enabling scale to zero, which allows customers to essentially turn off their workloads when not needed. And second, we're adding support for Carpenter auto scaling, or what we call auto node. Carpenter automatically launches just the right compute resources at just the right time, reducing compute cost. Next up, let's talk about Azure Red Hat OpenShift, or what we call Arrow. First, let's talk about our expanded regions. We're going to be launching Azure Government Texas and Arizona, as well as UAE Central, Mexico Central, Indonesia Central, and Austria. Next up, we have managed identities. This feature will utilize short-term credentials and more granular permissions when deploying and managing the Arrow clusters. This will significantly improve the overall security posture of the Arrow deployments. And next is Azure Lockbox enhancements. Azure Lockbox is a security feature that provides customers with explicit control over access to their data by requiring their approval before Red Hat SREs can access their data or troubleshoot or for troubleshooting or support. We're enhancing Azure Lockbox to include SSH and kubectl access. And finally, it's hosted control planes, where the control plane infrastructure is hosted by Red Hat and Microsoft on behalf of customers. This will offer cost savings, operational efficiency, and increased reliability to Arrow users. And finally, OpenShift dedicated on GCP, or what we call OSD GCP. First, we are increasing the maximum number of compute nodes supported on OSD and ROSA Classic from 180 to 249. This will allow customers to run more applications and services on a single cluster, thereby maximizing resource efficiency. Next, to drive the AI workload adoption, we're enabling a wide range of GPU instances. Additionally, we will provide flexibility to deploy GPU-enabled machine pools in a single zone and a specific subnet of a multi-AZ cluster. In addition to adding OpenShift virtualization, we will be enabling support for BYOL for Windows. This allows customers to bring their Windows Server licenses to our platform in a compliant way. And finally, building on the theme of integration with native GCP services, OSD will offer NetApp Astra Trident Operator out of the box. This will provide seamless integration with Google Cloud NetApp Volumes, which is the first-party service from Google and NetApp. Next, I will hand it over to Harriet Lawrence to talk about workloads and layered offerings.
Thanks, Jim. Next slide, please. Yes, this one. Now we would like to focus more on the ecosystem of products that OpenShift offers to provide a complete enterprise application platform on top of the Kubernetes layer. This is the comprehensive suite of operators that assist you in managing the complete lifecycle of an application. It will help you scale your GitOps workflows with environment promotions and a new type of sharding. Building applications with OpenShift builds and pipelines will become more secure with better isolation thanks to user namespace support and multi-cluster. Quay can then not only manage these build artifacts, but also the intermediate artifacts in the form of software libraries and make machine learning models for AI integrated applications discoverable. Running cloud-native applications becomes more efficient with ambient mesh supporting your microservices, and also serves as an easy entry into the world of post-quantum safe encryption for endpoints. Composing AI agents becomes possible with serverless, which will also be available on the edge. And with Migration Toolkit for applications, we'll be leveraging GenAI to help you streamline your legacy app onboarding. To not be overwhelmed by management, we're going to consolidate our console to a single view and also provide a single catalog to discover certified software and Red Hat layered products. Next slide, please. OpenShift GitOps has a lot planned for the next year. Some key highlights coming soon include native support for OCI repos as a source for your applications and a tech preview of the Argo agent. Next up, we're looking at bringing in the manifest hydration and environment promotion projects from the upstream community. And we're also planning improvements to how OpenShift GitOps manages certificates. Further out, we'll be implementing improvements to Argo UI's performance and accessibility. Another major feature on the horizon that we're really excited about is sharding based on applications rather than clusters. Quay will integrate with OpenShift AI's model registry with model card metadata indexing and introduce a Hugging Face compatibility layer to allow for AI engineers to work and deploy in air-gapped environments. Quay will transform into a full-feature artifact manager, starting with Python, Node.js, and Java. The lifecycle of all assets will be further automated with better automated cleanup based on actual usage and mirroring large content sets in one job definition. Next slide, please. Builds for OpenShift will focus on bringing cloud-native build packs, build strategy to tech preview, and then GA, and also creating guides and assistance for customers who are migrating builds from build configs to shipwrite. In the near term, user namespaces will be explored to enable image builds with Builder without requiring any special privileges. Dependency and image layer caching is another area that we'll be looking into for reducing the build times. In the longer term, we'll be working on introducing multi-arch build strategies so that customers who have heterogeneous clusters with worker nodes of different architectures in their clusters, for example, ARM and x86 nodes, are able to run a shipwrite build that creates images for multiple architectures, all orchestrated to the appropriate worker nodes. In our roadmap for OpenShift pipelines, we're focusing on making Tecton more efficient, multi-cluster, and easier to use in multi-tenant environments. We're launching a tech preview of the Tecton CD Pruner, an event-based tool to automatically clean up unused pipeline objects, helping teams optimize their cluster resources. In the midterm, user namespaces will become GA in OpenShift in the next version, and we will be taking advantage of that for running pipelines and building images in the user namespaces with Builder without requiring any special privileges. In the longer term, multi-cluster control plane for pipelines as code is an area we're exploring, enabling customers to provide a pool of clusters as the destination for the pipeline execution on Git events coming from a repository. Next slide, please. For serverless functions, we are working towards introducing Python templates for AI, the ability to deploy functions as raw Kubernetes deployments, and the use of functions and workflow for no-code AI agent composition. Another important feature for functions will be to offer various levels of support for AWS Lambda migration. For event-driven architecture, pre-factored sources and syncs such as AWS S3 and more, this will enable users to simplify asynchronous communication. To further empower AI and ML capabilities, support for integrating with popular cloud AI platforms, and adding drift detection for model reliability. On the platform side, we're looking to offer a serverless scaling integration with Kita. OpenShift Service Mesh 3 was recently released, and our next release will be version 3.1, based on the upcoming Istio 1.26 release. Most notably, we plan to include technology preview support for Istio's sidecarless ambient mode. By removing sidecars, Istio's ambient mode significantly reduces the resources needed to run Service Mesh, particularly for pod-to-pod encryption. We plan to make this feature generally available before the end of the year. In addition, the Istio CSR component, which allows Cert Manager to integrate with Istio, will soon be generally available. In the future, we are planning support for quantum-ready crypto algorithms, off-cluster workloads, and improved multi-cluster service mesh management with Red Hat's advanced cluster management. Next slide, please. We're focusing OLM v1 improvements on user experience, management, and flexibility. First, for user experience, we've got a new unified catalog UX, which streamlines package discovery in the console, backed by API improvements for more efficient operator metadata queries. Secondly, for simplified management, we're enabling broader applicability because OLM's v1's simpler APIs make GitOps and zero-touch provisioning integration easier across environments. We're also streamlining service account setup. OLM v1 will discover needed permissions and assist with service account creation, simplifying adoption while maintaining least privilege. Finally, flexibility and control. Simplifying migration and troubleshooting by optionally keeping resources during package removal. Also, you'll get more operator choices with new first-class Helm chart support. So all in all, OLM v1 offers a more robust, intuitive, and adaptable platform for OpenShift package management, and there is a lot more coming soon. The OpenShift console is the face of OpenShift and is a key component for tying together the OpenShift application platform. The console, with dynamic plugins, allows our layered offerings, our partners, and our customers to create their own unique custom user experiences. One of today's themes is simplification. So starting with merging the admin and dev perspectives, no more jumping back and forth. Users can accomplish their task in a single perspective. The dev perspective is still available if that is your preference. Patternfly 6 will provide a new look and feel that will be clean and crisp. Next up, we'll be adding support for OLM v1 in addition to v0, Helm, and more content. To simplify things even more, our goal is to provide users a single catalog for managing software and services that run on your cluster. And finally, we want to simplify the interactions between DevHub and the OCP consoles. Software templates generated specifically for deploying and interacting with your OpenShift cluster is a great way of doing that. Next up, we've got networking with Jamie.
Okay, thank you. Next slide, please. So Red Hat OpenShift Networking has a project named Universal Connectivity, which aims to provide seamless integration between our default networking, OVM Kubernetes, customers' external networks, and targeted networking solutions that cross over that boundary. User-defined networks, also known as UDN, is part of this, and it will aim to integrate our default networking, OVMK, and customers' external networks. Traditionally, the cluster pod network would be a layer 3 network across all the cluster nodes. And if you wanted a different isolated network for security, you would need to load additional CNI plugins. That's good enough for some deployments, but it doesn't have all the advantages of a Kubernetes primary network. This creates increased complexity and additional operational burden. With user-defined networks and the newly added VRF support, you can now carve out additional, isolated by default, primary networks for your pods and your virtual machines. So now you can have your own IP address range. VMs can have their own static IPs for the lifetime of the VM, and there's no need for NAT. You can attach to this just like your data center network. So what's the advantage of all this? If you have thousands of VMs that you want to migrate across OpenShift, you no longer have to re-IP them all. Huge advantage there. So UDN is already GA as of OpenShift 4.18. We're continuing it to refine it and add BGP support with EVPN integration in the coming releases. Next slide. So Gateway API, which is also known as Ingress API v2, helps you manage how your external traffic gets to your services running inside the cluster. Think of it like a traffic controller. So it provides a structured way to define where requests should go, how they should be handled, and who can access them. Gateway API can set up rules for routing and load balancing and even security policies like enforcing HTTPS or limiting access. Gateway API is more flexible and more expressive than the previous Ingress API. It makes it much easier to control your complex traffic flows. We already support Route and Ingress API today, and with the GA of Gateway API in OpenShift 4.19, alongside Service Mesh 3.0, we look to support Gateway API as part of the Ingress support. Next slide. Even more things networking. So eBPF-enabled Network Observability Operator is getting quite a few new enhancements. Right now, it ships with the UI in the OpenShift web console and gives you an interface to see networking traffic and network topology. So we're expanding the scope to multiple clusters, so you can now see the same thing in ACM. We're also expanding the number and the kind of metrics it captures to include cluster edge objects like VIPs, load balancers, and Kubernetes network policies that might be blocking traffic. So all of these enhancements improve security for admins and help developers validate and troubleshoot network applications. For eBPF Manager, eBPF programs allow developers to create a user space program that has kernel space privileges for network traffic. Because of this power, and especially in multi-tenant environments, administrators want to govern who can execute the eBPF programs, what they're allowed to do, and also have the ability to observe all of the running eBPF programs on a cluster. eBPF Manager targets that level of security and scrutiny that doesn't really exist anywhere else in Kubernetes. eBPF Manager is known upstream as BPF-Man and is in the CNCF sandbox and is currently under tech preview. We're looking to GA this in an upcoming release soon and then integrate with all of the current and future Red Hat internal eBPF implementations. And then finally, we're looking to extend IPv6 support on all public clouds in upcoming releases. So as end-to-end public cloud platform IPv6 support progresses, we're working with cloud providers to make sure that OpenShift networking will also support IPv6 dual stack deployments on the public cloud to match that. Next slide. And Red Hat Connectivity Link is happy to announce the upcoming release of version 1.1 in the beginning of May. So lots of new features in this release. The first of the highlighted features is the core DNS plugin that allows Connectivity Link to manage DNS policy on your own local DNS server, while also providing the same functionality you can already get on Connectivity Link's integrations with cloud service providers' DNS solutions. So this will include features like geo-based routing structures, traffic weighting, and load balancing. And the second of the highlighted features here includes support for Gateway API 1.2. So that will bring gRPC routing, WebSocket support, timeouts, retries, and lots of other new capabilities accessible via the Gateway API. And then finally, it's going to ship with preparations around policies for inference serving of AI models. Next slide, please. Okay, and now we can go on to observability. Next slide. Okay, so for observability and insights, in the near term, we have a lot of nice enhancements, including being able to deploy, use, and manage observability with the cluster observability operator. So one meta operator to manage your observability in your OpenShift cluster. We'll be enriching your AI experience with GPU and accelerator metrics and dashboards. So integrating those accelerator metrics with OCP dashboards and also with cost management. So application monitoring dashboards integrating with Red Hat Developer Hub for cost management. And incident navigation capabilities in ACM, and more OpenTelemetry integration on the edge with Red Hat Edge Management. A little further out, you'll be able to have a custom reports builder and cost management. Gen AI observability capabilities, more partner integrations coming, and then integrated analytics capabilities for OCP like incident detection and signal correlation. And then long-term, integrating with OpenShift Lightspeed for further troubleshooting integration. increased workload efficiency with right sizing, making sure that your workload is sized appropriately for your needs, not too big, not too small. And then adding native and custom dashboards for single and multi-cluster observability. Next slide. We are working hard to improve observability for OpenShift virtualization and also in Red Hat ACM for advanced cluster management. So in the near term, we're going to be increasing use of analytics features so that you can troubleshoot faster in ACM. So consolidating incident detection with alert groups, and then productizing right sizing for namespaces and virtual machines, moving that towards a tech preview. In the midterm, we will be consolidating the multi-cluster observability add-on in ACM, so being able to add more observability components through ACM, adding in cluster logging operator, cluster observability operator, Loki operator for log storage, and tempo operator for tracing storage. And then long-term, improving the observability section in ACM by leveraging Persis for customizable dashboards in ACM, consolidating the multi-cluster alerting UI, and introducing a multi-cluster logging UI. Next slide. And then finally, we are also working on enhancing the AI experience in observability. In the near term, we are working on OpenTelemetry schemas for AI workloads and getting those more integrated with Red Hat AI products, and integrating AI observability with the Dynatrace platform. Midterm, we're continuing with partner accelerations, again, leveraging Persis to get that one dashboard experience and also create customizable dashboards there. And then long-term, continued integration with OpenShift Lightspeed and other AI interfaces. So we want to be able to leverage observability signals and analytics so that you can use signal correlation, which is called correlator upstream, to get a faster idea of what's happening within your cluster and your AI interfaces. Incident detection, and then getting a better idea of cluster and components health with Cube Health. Next slide. And with that, I will hand it off to Christoph for the developer experience.
Thanks, Jamie. I'm excited to share some upcoming features. Soon you will be able to install plugins and configure plugins directly from the Developer Hub extension plugin. We are streamlining the developer feedback loop with RHDH local for easier plugin and template creation directly from your laptop. To boost adoption, our Quick Start plugin will offer a guided first-time user experience. And the Adoption Insight plugin will be available out of the box with the Dev Hub. Some key highlights include a new plugin certification program, FIP support, and a scorecard plugin to display KPIs such as technical debt, DORA metrics, and security posture. We are also enhancing template lifecycle management to ensure applications stay up to date with the latest templates. Looking ahead, expect localization for RHDH and customizable do-it-yourself homepage. Finally, we're introducing new AI features such as Developer Lightspeed, MCP Server, and OpenShift AI integration. Stay tuned for more updates. Next slide. Now on the Podman desktop, as we continue to innovate and improve the container experience, our focus remains on delivering a seamless and user-friendly interface for managing container and Kubernetes. Key highlights include mirror registries, enhanced Kubernetes support with more objects supported, an namespace selection. Additionally, we'll be adding a UI enabling to bridge to remote Podman host for greater control over infrastructure, and GPU acceleration support is continuously getting improved to speed up containerized AI workload from your local developer environment. To improve the user experience and simplify the configuration, we'll be enhancing the status bar, implementing a faster and simpler onboarding process, and revamping the dashboard for a more intuitive experience, enabling developer to provide better visibility in the environment, as well as discovering and guiding through key workflows. Additionally, we'll be looking at log UI and integrating a CLI client directly from the application. For those who are working with Red Hat technologies, we'll be adding a lot of improvement in the Bootsy extensions, which enable you to entirely code, build, test your bootable containers from within Podman desktop. We'll be introducing a new RHEL extension to provide easy access to RHEL environments from your Mac or Windows developer environment. To support developers working with OpenShift, a new extension will be providing the ability to run Microshift locally in a container, unlocking easy access to OpenShift for application developers. With those additional extensions and capabilities, Podman Desktop is making it very easy for application developers to work with Red Hat technologies on the developer environments. Next slide. Podman AI Lab is for developers already using working with containers and looking at bringing AI into their existing applications or creating new ones. Podman AI Lab is an extension that simplifies getting started and developing with AI in a local environment, ensuring consistency and streamlined transition to production. We'll continue to unlock the power of local inferencing and leveraging GPU. In addition to Llama CPP, we'll add the support of OpenVINO and VLLM. Llama and Podman AI Lab are converging. If you are not aware of Llama, it's a fully open source project to allow local management and serving of AI models locally. It works from the CLI, and in many ways, Llama and Podman AI Lab are enabling similar use cases. So the two projects will converge, enabling consistent CLI and UI experience. To enable quick experimentation with AI, developers will find more recipes to start and get experience from. For agentic development, we are looking at helping the developers to easily work with Llama Stack as well as MCP server. You probably noticed that MCP servers are becoming very important topic, and as they unlock LLMs to communicate with different tools. They are very interesting for developers working with AI tools, and we'll be looking at that. Moreover, we will also you will see also more capabilities shaped around helping developers to build and test agentic applications leveraging those technologies. Next, I will hand it over to Maria to talk about security.
Thank you. 2025 is the year in OpenShift for workload identity. We will do this by incorporating a SPIF and Spire. But first, if you're not updated, what is workload identity? It's just another way to assign a unique identity to a workload, basically to verify identities to application services, and to help them authenticate communicate in a secure manner without relying on hard-coded credentials or API keys. We will do this with the SPIF and Spire, and SPIF is a framework that securely assigns unique identifiable credentials to workloads. Spire is the open source implementation that automates the whole process of creating, managing, and verifying these identities. All of this will come in the form of an operator. The operator will be called Zero Trust Workload Identity Manager. It will be a day 2 operator, which will be on tech preview in 4.19 and will be GA on the upcoming release. We are also planning to bring integrations to the existing OpenShift services to enable additional use cases for identity protection in AI, virtualization, and other areas. Just as a summary, this new operator helps you secure identities for workloads in a complex environments like multi-cloud and also multi-cluster systems. With the next slide, we move on to ACS. In the area of vulnerability management, we want to help customers prioritize better the vulnerabilities. Because of that, we have done a lot of improvements in the platform. One of the latest one was the EPSS scoring that was included. We are now planning to add additional things. Like, for example, there's a CISA field, which is called known exploited vulnerabilities, which could help you prioritize further your vulnerabilities. We'll tell you which CVEs are known to be actively exploited, and we are planning to add this as well in the upcoming releases. Also, to provide a very clear identification on accountability, we will make a distinction between which CVEs affect the base image layers versus the additional layers that are introduced by developers, just to understand where does the CVE land and who is in charge of patching it. For ServiceNow users, we are working integrating the ServiceNow vulnerability response. This enables organizations that prioritize CVEs using this tool more effectively and specifically support SLA-driven workflows through this process. OpenShift virtualization, you also know, has been big this past year and this year. ACS wants to also step up, adding vulnerability management for VMs, having a single pane of glass across both for containerized workloads as well as the VMs. On the risk profiling front, the key is to make risk more, first, intuitive and two, actionable. We are planning a set of improvements, like I can interface RBAC insights, policy-based access control, customizable risk dashboards, and also AI-driven recommendations that are tailored to your specific organization needs. And also with the release of Compliance Operator 1.7, which is integrated with ACS, we have a brand new set of profiles. We have now the latest and greatest of this ST and CIS for OpenShift, but also we have introduced yet a new profile, which is specific to the German Federal Office for Information Security. All of these profiles will be able to run through ACS as well. Because we think that compliance is not just infrastructure compliance, which is what Compliance Operator takes care of. We want to also target and improve the application level compliance. So customers, when they reach to ACS, they can get a holistic view, not just about what is happening on OpenShift, but also what is the compliance status of the application. And with OpenShift virtualization, we will bring a new profile in the future for OpenShift Virt. And with this, you also will be able to run this profile through ACS. We're also aware that a lot of our customers are using tailored profiles, and ACS will provide ability to visualize the results to schedule these tailored profiles to a single place for a multi-cluster. Next slide. In the area of policy, in 4.8, we will GA policy as code. Policy as code has been one of the most requested features from our customers. We are planning to add additional enhancements in the upcoming releases to get it like fine-tuned to make sure that, you know, customers are able to utilize it in any single situation that they are interested in. Also, in terms of reporting, vulnerability management has been a lot of customers have requested similar type of reporting to the one that we have in vulnerability management for violations. We will make that available as well. And also we are planning to integrate with other policy engines. In the front of networking and runtime, now we have external IP information. So this will surface in different forms in ACS, as part of the network graph, but also more powerful as part of policies to alert about suspicious activity. You will now have, you know, the concrete IP address that it is performing that action. And to basically be able to continue the journey of OpenShift networking, ACS will be aware of the newer ways of isolating. So UDN and also admin network policies, which was released some releases ago. On the platform front, we plan to support FIPS 140, which means that ACS will be designed for FIPS and obeys for FIPS 140 regulatory requirements. Also, customers that want to bring their own database, we are planning to support Postgres version 15. And we will also introduce support for the first ever post-quantum algorithms for digital key exchange. And now I'm passing it over to Sean for updates on cluster management.
All right, thanks, Maria. So let's jump right into what's happening next with Red Hat Advanced Cluster Management. So to kick it off with virtualization, obviously a really hot topic. First off on our plate is we're bringing the fine-grained RBAC capabilities to the multi-cluster OpenShift virtualization experience. So this is going to allow you to implement some precise access controls across clusters and sets of VMs so that your teams only can see and do what you allow them to do. And after that, we're looking to see how we can help facilitate the live migration of VMs from one cluster to another. And then I'll make some important tasks such as infrastructure maintenance operations much simpler and easier. And then keep a lookout for a launch out experience to each VNC console, all from the ACM dashboard. In the cluster lifecycle area, we're bringing a long overdue capability to rename your hub cluster. So if you haven't been a fan of that pesky local cluster name, you'll soon be able to change it. And along the lines of long requested features coming into ACM, we're finally going to be providing a way for you to provision ROSA hosted control plane directly from ACM. And that's coming from work that we've been contributing up into the cluster API project and bringing back down into Red Hat. And after we do that, we're going to look to see how we can provide some similar capabilities that will integrate with a future availability of Arrow HCP when that's available. And then finally, in this area, we're looking to see how we can improve the process by which the cluster certificates can be customized and rotated, and doing so without disturbing the connectivity between the hub and managed clusters. In the governance arena, we're bringing to general availability the pre-deployment capabilities to test your open cluster management policies in something like your CI pipelines. And then we'll be continuing our story around multiple policy engine governance that we have been providing with other policy engines like Open Cluster Management, Gatekeeper, Hiberno, validating emission policy. And we're going to be looking to see how we can bring in Red Hat Advanced Cluster Security policies into the fold to provide a complete and unified management and governance experience across all of your policy engines. Next slide, please. In the application lifecycle space, we've been collaborating with OpenShift GitOps to bring a technology preview of the progressive sync feature that's been in Argo CD. This allows for a progressive delivery or a progressive rollout capability of your Argo CD applications across multiple clusters. And after that, we're looking to see how we can improve the management experience of OpenShift GitOps itself by introducing an ACM add-on that will handle all aspects of the lifecycle management of Argo CD across your fleet. And furthermore, the upstream work that's been going around the Argo CD agent-based model that provides a hub spoke and distributed architecture for Argo CD will be integrated into ACM at a later date. And then finally, I have some exciting news to share that very soon, we will have an on-demand offering of Red Hat Advanced Cluster Management coming to the AWS Marketplace. That's going to enable a streamlined consumption model with all the billing handled centrally within your AWS account. And once that lands, we're going to be working really hard to bring some similar offerings to the Microsoft Azure and Google Cloud marketplaces. That's all I have for Red Hat Advanced Cluster Management. I'm going to hand it off to Hari from here to talk about Telco and the Edge. Thanks.
Yeah, thank you. So next slide, please. Let's jump into Red Hat Device Edge and Microshifts. Those are the Edge platform, we focus on the far edge and small footprint deployment, where we continue to enhance AI model serving capabilities with Microshifts. In parallel, we work as well on generic Kubernetes device plugin that will simplify access from pods to edge devices, peripherals such as cameras, serial ports, sensors, and so on. Next slide, please. We continue our investment in the two nodes OpenShift topology to support use cases in retail and industrial edge deployment. The first variant, which is on this slide, is what you call, the two nodes with arbiter, also known as the 2+1. The third node can be a small and cheap system. That third node is running only etcd component to ensure quorum and consistency. We plan to fully support OCP virtualization on this topology, and we are on track for tech preview in OCP 4.19 and GA later this year. Next slide, please. The second variant is two-node OpenShift with fencing. It uses fencing to ensure consistency in case of network split brain situations. The solution supports only local storage. The feature is planned for development preview with OCP 4.19 and tech preview later that year. Next slide, please. From a telco standpoint, our main focus is really to continue our investment in achieving operationalization at scale and leveraging existing OCP functionalities to fully support telco use cases. Drive and align, with the ORAN standard and enable new hardware to provide new functionalities to our customer to better service their use cases. Next slide, please. As we look ahead at our cloud activities, we're focused on strengthening our positions within the ORAN community. Right now, we are actively contributing to ORAN Working Group 6 and 11. Those are the key forums, for shaping the future of the cloud architecture and its security framework. This engagement allows us not only to stay aligned with the evolving standard, but also to influence them directly, ensuring that our solution remain both compliant and forward-looking and shape the future direction of the entire ORAN framework. At the core of our current work is the expansion of the hub cluster functionality. We're enhancing it to support full lifecycle management of both the CAS platform and the underlying hardware. We are also focused on making our workload component agnostic to both SNO and RAN workload. This flexibility is a key for us, for broad deployment scenario and applicability as well outside the RAN verticals. Looking ahead to the next 6 to 12 months, several key investment areas are taking shape. We are placing significant emphasis on Metal Cubed as our open source solution for hardware management. This will give us a scalable Kubernetes native way to manage bare metal infrastructure, which is critical in edge and telco environment. We are also advancing our day-to operations. The goal here is really to simplify operations and improving resilience in real-world deployment. We will be building the cloud observability capabilities using cloud-native based practices to ensure that we can support large-scale distributed deployment with confidence. In parallel, we are enabling a certain number of use cases scenario, including single node OpenShift with DU profile, combined CU/DU, and even full mobile network operator configurations. Next slide, please. For our telecommunication partners to achieve the best return on their use cases, hardware plays a critical role. Later this year, Intel Sierra Forest CPU will be validated for 5G use cases and added to the 5G core reference design specifications. On the RAN side, the next critical timeline is the introduction of Intel Granite RapidD systems. This is more powerful than SPR-EE. It comprises of CPUs, VRAM boost, and integrated NIC, which will be available by end of 2025. Red Hat is working closely with Intel and third parties on a set of milestones to fully support this hardware. We plan to achieve SPR-EE equivalent in OCP 419 as dev preview and deliver Grandmaster clock support as tech preview in 419. We expect to have full functionality with regression on commercial hardware in Q1 2026. For ARM-based CPU, the intent, of course, is to achieve full telco edge use cases with the same experience as OpenShift-based x86. The near-term focus is on NVIDIA Grace Hopper. For the DU use cases on SNO, we plan a tech preview in 420 and a GA in 421. CU use cases is being targeted for tech preview in OCP 421. Finally, for AMD-based CPU, the first generations Genoa and Bergamo are fully supported and integrated into our 5G core solutions. We added LLC, our awareness CPU pinning for better performance if the workload can leverage that functionality. For the latest AMD Turin CPU, we expect to include it as part of the 5G core solution later this year. And finally, for the long run, we are working hand in hand with AMD for upstream support of node resource interfaces. That's all I have on the telco and the edge side. I hand it over to Nick.
Hey folks, thank you for joining. We have just one last announcement on some upcoming events that will be important for you guys. So specifically, the next time you find us, it could be in person. There are just 19 days left until Red Hat Summit kicks off in Boston, and we do hope to meet many of you there and talk live about all the things about OpenShift. So find us in the booth at OpenShift Commons, or in the dev zone, or in the sessions and labs we'll be hosting on virtualization, AI on OpenShift, security, app development, cloud services, and more. So with that, thank you everyone for joining today. That is going to be our What's Next session for today, and they will be publicly published eventually on YouTube as, published on YouTube. Feel free to check out these features or learn at learn.openshift.com or try.openshift.com. Thank you again. We look forward to seeing some of you at Red Hat Summit.